In this video, we're going to be graphing inequalities in two variables. So you can see here on this first line, I'm going to shade the part of the xy plane that satisfies the inequality y is less than 1/2 x plus 3. We're going to use a table of values just to kind of show why what we do is what we do. All right, so first I'm going to take x is -2. I'm going to plug it in, get half of -2 is -1 plus 3 is 2. So we're going to have that the y's are going to be less than 2. So whenever x is -2, y is less than 2. So like an open dot there. I don't know if you can see this. Let's see if that works. And it's going to look along those lines. Then I'm going to repeat this for 0, 2, and 4. And so I'm going to stop it and it'll. So you see what I've done when x is 0, y ends up being less than 3. So that means that it's going to be all the numbers, any number less than 3 will make this true if if y is less than 3. Same thing, I did it repeatedly. And you can kind of see here that it's, of course, everything under the line. So that's the kind of goes with the less than. So it's less than, so under that line. And you can see that the line itself has a y-intercept of 1, 2, 3. And you got the slope of up 1 over 2, up 1 over 2. So this actually here is a graph of the line, and it kind of come down like that. So you can kind of see there's going to be a line there, but the numbers on the line themselves are not solutions. So notice that the graph up here of y equals 1/2 x plus 3, so the line itself splits the plane into 3 regions. Those above the line, those below the line, and the ones that are on the line itself. All right, so here's our steps. To graph a linear inequality in two variables, you're going to replace the less than or greater than with an equal. You're going to solve the equation for y. It's an important step. You're going to graph a dashed line if the inequality is less than or greater than, and graph a solid line if the inequality is less than or equal to or greater than or equal to. So then it should be, if it's greater than, it's going to be above the line, and if it's less than, it will be below the line. Another thing you can do is test a point in one of the below or above. Just take a point that's here, like the point 0, 0, and put a 0 in for the x and a 0 in for the y, and see if it's true or not. It would be true for this one. If it's not true, then the answer's on the other side. All right, so example 2, we have y is greater than or equal to 3x. So I'm going to think in terms of graphing the line y is equal to 3x. So there's a y-intercept of 0, so 0, and then a slope of 3, so up 3, 1, 2, 3, over 1. So I'm going to do that a few times, graph that in, down 3, back 1. Because it's greater than or equal to, it's a solid line. And so I'm going to connect this here. And then because I have greater than, I'm going to shade above it. And again, if you're not sure what side is above it, then test a point on that. So when I shade above it, I'm going to have this here, this section shaded on that. So what that means is that every point in this shaded area is a solution to this. If I pick an x and a y, for example, 0, 3, put a 0 in for x and a 3 in for y, 3 is greater than 0, and it comes out to be true. So every point in this section will make this inequality true. So x is less than 5. Of course, we're going to graph x is equal to 5, which is going to be a vertical line going through 5. So here, it's less than, so it's going to be a dashed line going through 5. So dashing down the page there. So there's my 5. Now I need to decide if it's less than. Now there's not going to be any above or below here. So what side do you think that x is less than 5 would be on? You can kind of see here, like 4 is less than 5. So you know you're going to go this direction for my less than. So that whole section is going to be the solution. All right, so now when I get 2x minus 3y is greater than or equal to 12, I see that it's greater than or equal to, so it's going to be a solid line when we graph it. I need to solve this for y, so I'm going to take a negative 3y is greater than or equal to, subtract my 2x plus 12, and then I'm going to divide through by the negative 3, so negative 3. And when I divide through by that negative, recall that it flips the inequality, and that's why it's going to be important to solve it for y and keep your inequality there. And remember that if you divide by a negative, that it's going to flip. So I get that y then is less than or equal to negative negative makes it positive 2/3 x, and then minus 4. So I'm going to graph that. So I have a negative 4y intercept, and then up 2 over 1, 2, 3, 2 over 1, 2, 3, down 2, back 1, 2, 3. And again, we said it was a solid line, so a solid line here. And when this flips, so I'm going to go by this, not that. I'm going to go by the one where I've got it solved for y. The y's are going to be below this line, so we're going to shade in this direction here. All right, one last problem, and that would be to write an inequality for this graph right here. And so I need to get the equation of the line. So I see it's going through 1, 2, 3, it looks like, so 3. So that's going to be my y-intercept, and it appears the slope is up 1 over 1, 2, and 3. Oh, that's right. Can't see that good there. So I'm going to say the slope is 1/3. So m 1/3, b appears to be 3. So I'm going to say that my equation is y is equal to 1/3 x plus 3. I see that it's shaded below it, so and the line is solid, so y is less than a solid line makes it equal to 1/3 x plus 3. All right, so watch the next video over solving systems of inequalities with graphs.